Good afternoon, class. We are looking at the synopsis of exam 2 review, which covers from 3.1 to 3.8. This is the third part. We are interested in derivatives of the log functions now. The derivatives of log functions, everybody, we're going to cover. So we start with y equals ln x, and we want to take the derivative of that. We remember how to take the derivative of exponential functions. For example, y equals e to the power of x is itself. But we haven't dealt with logs. So the best course of action is to put it in an exponential format since we are familiar with that. So we're going to write it e to the power of y equals x again. Let me quickly remind you of that d dx of e to the power of x is itself, okay? So, and the d dx of e to the power of g of x is e to the power of g of x by the chain rule times g prime of x. So that we know. So that's why we use the exponential format to figure it out. Now, of course, we're going to use implicit differentiation. The derivative of any exponential is itself, e to the power of y. And remember, y is like g of x. So times y prime or dy dx, the derivative of x is 1. This is implicit differentiation. And y is the function of x. We are interested in finding y prime or dy dx. So it's 1 over e to the power of y. And as you know, e to the power of y is x. We proved the derivative of y equals ln x is 1 over x. So when we expand that, the derivative of ln x in an absolute value is 1 over x. As you recall, x of course can't be 0. As you recall, we put it in an absolute value because the domain for natural log is from 0 to infinity. If it's g of x, 1 over g of x times g prime of x. Needless to say, g of x can't be 0. And if it's ln u, 1 over u du dx, this is by the chain rule. This is by the chain rule. Du dx is also by the chain rule, okay? Now, let's move on. Let's remind everybody of logarithmic rules again. When x is b to the power of y, by definition, y or log x or log x base b are the same. In other words, if you write it in this format, and take a look at the arrow that I'm going to give you, this arrow, b to the power of y is x. I'm assuming, of course, we're calculus students, we have no problem with that. As long as we can go from one format to the next, we're going to have easy time with logs. And so, as you recall, these are logarithmic properties. Log of 1 with any base is 0, or you can go with b to the power of 0 is 1. Log b base b is 1. B to the power of 1 is b. These two refer to the fact that logarithmic functions and exponential functions are inverse functions. Therefore, log of b to the power of x when the base is b is x, b to the power of log x base b is x. This is the product rule. This is the quotient rule. This is the power rule. And if you translate that into a natural log where the base is e, number one, we don't use log, we use ln. Whenever we use ln, we mean the base is e. Then y equals ln x means e to the power of y equals x. Log 1 becomes ln 1. Log b base b, that means ln e equals 1. These two are numbers 3 and 4. Ln of e to the power of x equals x, and e to the power of ln x equals x. The other three, you just change the log to ln. As you know, y equals e to the power of x and y equals ln x are inverse functions. Therefore, it makes them symmetric with respect to the line y equals x. And as far as the common log, as you remember, the base is 10. Therefore, when we write log x no base, means the 10 is there. And that means x equals 10 to the power of y. And this is the general format. This is specific for base 10. Base 10, we just don't write the base p. And therefore, understand log 10 is 1, log 10 to the power of x is x, and so on and so forth. And of course, everybody is familiar with the change of base form. Finally, we added the differentiation rules. Okay, so the derivative of ln x is 1 over x. Okay, and if it's ln of g of x, 1 over g of x times g prime of x. If it's log x, in other words, the base is no longer e, and then we divide by ln b. If you recall, in the case of exponential, we multiply by it. We will look at that later on. But for now, let's start with a very simple example, which requires knowledge of logarithmic properties. If you want to differentiate this, you want to decompose the log, and I'm going to assume everybody knows how to do that. So 1/2 remains. This is log of the top from the bottom. So ln of 1 plus x minus ln of 1 minus x. If you don't do that, you have to write the reciprocal of this and then differentiate this one by the quotient rule. Most students who don't recognize this easy way out, they make a mistake. Make sure you know that for your exams. So make sure you're comfortable with the property. So now 1/2 remains. If you want to differentiate this, just look at this one, flip this over. So we have the 1/2. First we have the 1/2. Then we flip this over, becomes 1 over g of x or 1 over 1 plus x times the derivative of the inside, which is 1, minus, flip this over, 1 over 1 minus x, and by the chain rule times g prime of x. The derivative of the inside is negative 1, everybody. Now let's take a common denominator. This is 1 plus x times 1 minus x. This 2 is 1. Okay, 1 times 1 minus x. This 2 would be plus 1, minus 1 and minus 1, plus 1 times 1 plus x. Okay, so we have 1 minus x plus 1 times 1 plus x. So the common denominator and then the rest. All you have to do is simplify the numerator, and here's what we get. And I hope you see that it's 2. The 2 cancels out the 1/2, and we get 1 over 1 minus x squared, because the product of these two is 1 minus x squared. So again, as you can see, a lot of algebraic steps. Okay, a lot of algebraic steps. This was the only calculus step. So we should be very comfortable with algebra, and everything will fall into place. We want to differentiate ln of sine theta. So we look at this one. The argument is sine theta. Flip it over. 1 over sine theta times g prime of x. What is the derivative of sine? Cosine. And everybody knows cosine over sine is cotangent theta. Y equals e to the power of x over 1 minus e to the power of x. And we are going to use the quotient rule. Therefore, I'm going to call this f over g. I'm going to use f prime g minus g prime f over squared. So f prime is e to the power of x itself times the bottom, put it next to it, 1 minus e to the power of x, minus g prime, minus the derivative of e to the power of x is itself, but it does have a negative sign in front of it, so it remains. This is minus g prime, now times f, times e to the power of x. And then you just write the bottom and square it. You write the bottom and square it. It's very straightforward, everybody. Okay. Now, All we have to do is simplify the numerator, everybody. Let's just simplify the numerator. E to the power of x. I hope you recognize the product of these two is minus e to the power of 2x because you add up the x's. And minus makes it plus e to the power of 2x again. And obviously, these two cancel each other. The numerator has only e to the power of x. All right, let's try this ln of 5x. If it helps, literally change this to g of x. Just change it to g of x. So that means 1 over g of x times g prime of x. So 1 over ln of 5x 1 over ln of 5x. And now we need the derivative of ln of 5x, which itself uses this formula. Now, I want g prime of x. What is the derivative of ln of 5x? 1 over 5x. I'm going to flip this over. 1 over 5x, and then times the derivative of 5x, which is 5. So I hope you see how we are working on that. Now, this 5 cancels out this 5. And this is the final answer. And we put the x in front because otherwise it's awkward. So we put the x in front of ln of 5x at the bottom. And we are done. We want to take the derivative of log base 3 of square root of x. And we have dealt with ln when the base is e. But I want to show you how we arrive at the answer because I did give you the formulas, but let's quickly remind everybody how we arrived at it. And that is using the change of base formula. When you have log x base b, you can write it as ln x over ln b. And please understand, it means the same as 1 over ln b times ln x, where 1 over ln b is just a number. So now this, I know how to take a derivative because this is going to remain the same, and this is going to be 1 over x. Why is this going to remain the same? This is a number, everybody. 1 over ln b is a number. B is a number, so is ln of b. And so 1 over ln b times 1 over x. Therefore, y prime is 1 over x ln b when we put them together. So we are going to rewrite this in the following manner. X to the power of 1/2. 1/2 sits in front according to the power rule. And now 1/2 remains. I'm going to take the derivative of this one. So I need the 1/2, and then log, I'm going to flip this over 1 over x. Because the base is not e, because it's not a natural log, I need 1 over ln b, 1 over ln 3. Now I'm going to put them all together. And 1 over 2x ln 3. This is the way you would write that. What if we have, instead of x, a function of x, in this case log base 5 of x squared plus 1, the only thing we add is the chain rule, everybody. So in general, if we want the log, we want to take the derivative of a log, with a different base like such as b of f of x. We flip this over, 1 over f of x. Then we multiply by its derivative f prime of x. And then because the base is not e, 1 over ln b, 1 over ln b. This has got to do with the change of base formula. So the first question, can I simplify this logarithmically? Can I use properties of logs to do so? The answer is no. So flip this over. By the way, if you put this together, I rather go with that and then simplify. But if you put this together, it's 1 over f of x times ln b times f prime of x. But I'm going to stick with that. Flip this over. Multiplied by its derivative, 2x. Is the base e? No. 1 over ln b, 1 over ln phi. So whenever you want to answer a question, write the formula from your memory. You have memorized the formula. And now apply that. So just follow that formula and now put them together as the following. 2x over x squared plus 1 times ln phi. If you put the parentheses after phi, 1 may be under the assumption is the natural log of 5 times that. So that's why we put it in this format. We're going to take the derivative of y equals ln of 5x over x squared plus 5. And you want to decompose the log first for a simple reason, because otherwise you have to flip this over, multiply by its derivative using the quotient rule. Instead, this is the natural log of the top minus natural log of the bottom. And the top is ln 5 plus ln x. So I hope everybody is comfortable with logarithmic rules. Ln of the top this whole thing is ln of 5x, okay? Minus ln of the bottom. Now, it's better to cut them into two pieces because ln 5 is a number, the answer is 0. So this gives you 0. This gives you 1 over x. Minus, flip this over, 1 over x squared plus 5. And by the chain rule, times g prime of x, times the derivative of this piece, which is 2x. And we are done with calculus. See, algebra, this is the only calculus step. Again, for emphasis, I'm going to put an asterisk next to it to mention there are many algebraic steps. Now, the common denominator is obviously x times x squared plus 5. And so 1 times x squared plus 5 minus 2x times x. 1 times x squared plus 5 minus 2x times x. I'm assuming nobody has any problem with finding LCD and so forth. So all you have to do is simplify the top. So we are going to have x squared plus 5 minus 2x squared. We can combine these two and we are done. So we get minus x squared plus 5 over x times x squared plus 5 as the final answer. We want to take the derivative of log of 9 minus x cubed to the power of 4. Well, first and foremost, I like to decompose the log. So I'm going to bring the 4 in front using the power rule for log. Then in order to differentiate this, first number 4 is the multiplier, and I'm going to keep it. Then since I'm dealing with log or natural log, makes no difference. I'm going to flip this over first. 1 over 9 minus x cubed. Then I'm going to multiply by the derivative of the argument minus 3x squared. Finally, I go back and look at that and see it's log, it's not ln, which means the base is not e. And since the base is missing, that means the base is 10. It's a common log. So 1 over ln b, 1 over ln b, that means 1 over ln 10, 1 over ln 10. So as you can see, they are all at top. That means 4 and negative 3x squared gives you negative 12x squared. This one and ln 10, so 9 minus x cubed and ln 10 are at the bottom. And this is our final answer, everybody. Again, very straightforward. There is not much to it. Okay, everyone. X squared times ln x. Let's find the equation of a tangent line, and I'm going to put a raised dot in between first and foremost because I want to find the slope. To find the slope, I need to differentiate. To differentiate, I'm going to use the product rule. So I'm going to call this f times g. So according to this formula, f prime is 2x times ln x plus g prime, the derivative of ln x, as you know, is 1 over x times x squared. So we are looking at this part. A simplification, this is fine. This becomes simply x, so plus x. To find the slope, you have to plug in. One way to write that, you can write m is y prime such that you plug in the pair. Sometimes it's a function of x and y. That's why I put them. Just plug in 1. Y prime of 1. If I plug in 1 here, I get 2 times 1 times ln 1 plus 1. And as you know, ln 1 is 0, so the answer is 1. Y minus y1, y minus 0 equals m1, x minus x of 1, 1. And as you can see, it's simply y equals x minus 1. All right, we want to differentiate this. And first thing first, we want to simplify. There is no way to simplify it. It is what it is. So we are going to stick with what the formula was. And the formula says, flip this over. So dy d theta. Theta is the independent variable here instead of x or t or something. So dy d theta is 1 over 1 plus theta ln 3. That means just flip this over. You can put it in any order you want. Okay. You can multiply it by the derivative, which is ln 3, and then just 1 divided by natural log of the base. The natural log of the base happened to be the same as that one, so it's ln 3 also. So we have 1 over ln 3 times ln 3. Okay. As you can see, they cancel each other. These two. So basically, we have the first fraction. And that's the final answer. Now, also, I want to remind you of the change of base formula. You could have written this one. If it makes it easier to remember, you could rewrite this as ln of the same thing over ln3 and now differentiate this. Understand, this is, let me rewrite that. If you want to go this route, this is the same as 1 over ln3 times ln of 1 plus theta ln3. If it makes it easier to remember it. And now differentiate this one. So you don't have to worry about it. That's why this ln3 here, okay? All right, we want to take the derivative of this function. Anytime you're dealing with logarithmic functions, if you can simplify, you must. So let's see how we can do that. ln of 2 e to the power minus t sine t. I hope you recognize that you can use the product rule. Ln of 2 plus ln of e to the power minus t plus ln of sine t, because we are multiplying these three pieces. I put them in different colors so it becomes clear. We are multiplying three pieces, everybody. And so we are going to cut them in this fashion. Okay, ln2 plus ln of e to the power minus t plus ln of sine t. This you should recognize as negative t, right? Ln of e to the power minus t. Remember, ln of e to the power of x is x. So ln of e to the power minus t is minus t. Now let's differentiate. ln2 is a number. The answer is 0. Minus t, minus 1. Plus this last piece, 1 over sine t, right? According to this one. Flip this over, 1 over sine t, and then the derivative of that is cosine t. So 0 minus 1, and then 1 over sine t, and times cosine t. Now, this remains as negative 1, and this, I hope you realize, it's cotangent t, everybody. So it's cotangent t. All right. So negative 1 plus cotangent t. We want to differentiate this, and again, we are going to use our algebraic techniques to make life easier. When we look at this part, e is being raised to the power of sine t times ln3. I can put them in any order I want. So I'm going to put ln3 first and then sine t. And remember, ln of e to the power of x is x, e to the power of ln x is x. So first, let me just make the change. When I make the change, now e to the power of ln3 is only 3. So now this changes to t log base 3 of 3 to the power of sine t. I can use the power rule and put the sine t in front. Or some of you may recognize it's just simply sine t. Okay? But let's say we have this and this is 1. So it's t sine t. So we haven't done any calculus yet. We just showed this is the same as this one. Therefore, we are going to use the product rule. F prime 1 times g sine t plus g prime cosine t times f, which is t. Now, this is important to put the t in front because we don't want anybody to think it's cosine of t squared. So this remains unchanged, sine t. This becomes t cosine t to be on the safe side. logarithmic differentiation. If the function is complicated like this one, if you want to differentiate this the way you've learned it before, it takes a long time. So we use what's called logarithmic differentiation. So what is logarithmic differentiation? Number one, take the natural log of both sides. That's the first. So ln y. Now, please understand, we want to decompose this. So we are looking at ln of this, right? So this is ln of the top. Let me write it here, ln of the top. And I'm going to write x squared plus 1 to the power of 1/2 minus ln of the bottom. Again, your algebra, your logarithmic property, knowledge of logarithmic properties will help. This piece, only this piece, is 3/4 of ln x plus half of ln of x squared plus 1 minus 5 ln of 3x plus 2. This refers to the knowledge of logarithmic properties, okay, which you should be very comfortable with. Now I'm going to differentiate both sides implicitly with respect to the independent variable. It happened to be x, but if it's t or theta, so be it. So clearly this is 1 over y times either y prime or dy dx. So 1 over y prime or dy dx. Let's go with this one. 3/4 times 1 over x. This one plus 1/2. Flip this over, 1 over x squared plus 1 times its derivative, which is 2x. Okay, all we have to do, look at the last piece and do the math. 5 remains, 1 over 3x plus 2, flip this over, and then times its derivative, which is 3, everybody. We are done. We are going to simplify things. How do we simplify this? There's really not much you have to do. Notice that dy dx is y. What color do I want to use? This side, if you take the 1 over y to the other side, that means multiplied by 1. That's all. And of course, what is y? You write this one. This one is 3 over 4x. This one, class, this 2 cancels out this 2. So this whole thing is x over x squared plus 1 minus 5. Oh, I forgot times 3. Times 3, I thought I had it. I did show that. But anyways, minus now 15 over 3x plus 2. So y, so we are solving for dy dx. Y times 3 over 4x, x over x squared plus 1, minus 15 over 3x plus 2. And the y must be replaced with what we had there. in the first place. All right, let's look at this one. We want to differentiate when you have a function being raised to the power of another function. You need logarithmic differentiation anyways. So to do the logarithmic differentiation, you're going to take a log, natural log of both sides. When you do that, this sine x sits in front according to the power rule. So you're looking at the product rule, the sine times ln. So we are going to take the derivative with respect to x implicitly. As you know, ln y gives you 1 over y times y prime. The derivative of sine, okay, so let me just write this as f times g. So this is f times g, and we are going to use the product rule, everybody. So I need f prime, which is cosine x, times g, which is ln x, plus g prime, the derivative of ln x is 1 over x, times f, which is sine x, and we are going to multiply both sides by y. So if I multiply it by y, can get rid of this and say this is being multiplied by y. I'm going to replace the y, everybody, with x sine x. This is cosine ln x, and this is 1 over x sine x, or you may write it as sine x over x. Either way is fine, everybody. So we want to solve. This is what we get. 1 over x sine x or sine x over x. Whatever is easier for you, that's just as good. Let's go with the derivative of inverse trig function. So the derivative of sine inverse is 1 over square root of 1 minus x squared. Cosine inverse is the same thing with the negative sign. Tan inverse is 1 over 1 plus x squared. Cotangent inverse is the same as tan inverse with the negative sign. So pay attention to this. Secant inverse is 1 over x squared of x squared minus 1. Cosecant inverse is the same as that with the negative sign. So if you know 3 of them, you know the rest of them. And I'm going to remind you of the relationship that we have among trigonometric functions and their inverse functions. When sine inverse of x equals y, that means sine y equals x. And that means this is the restriction we put. And that also means sine inverse of sine x is x, as long as x is between negative and positive power over 2 inclusively. Sine of sine inverse of x equals x, as long as x is between negative 1 and 1. For cosine, we have the same situation, but cosine between 0 and pi, this works, and this one between negative 1 and 1. And again, all of those that we have here. So sine inverse, take a look at this. Sine inverse, cosine inverse, the same as that with a negative sign. Tan inverse, 1 over 1 plus x squared. Okay. Now, cotangent inverse is the same thing with the negative in front of it. Okay. And now what I'm adding, what if we have a function of x? Over here, if you have a function of x, so you put that function here, and then you put du dx there. And that's what I put here. For example, for the first one, d dx of sine inverse of u, the two, just simply put times du dx. So you can put it at top. And instead of 1 minus x squared is 1 minus u squared. We may call this g of x. Then this is g prime of x. And square root of 1 minus g squared. That's what we've done with the tangent. Look at this one. If I change the x to g of x, this becomes 1 plus g squared at the bottom. And the top is just g prime. This is g prime, everybody. We just use a different color on purpose. This is g prime. Okay. It's extremely important to know that. Okay. Or the udx, just simply put you multiply by. Now, what I want to do, I want to remind you of the proof, for example, for sine inverse. Again, these are the formulas: sine inverse, tan inverse, secant inverse. Now, cotangent inverse is the negative of tan inverse, secant inverse, and cosecant inverse. This is 1 over x squared of x squared minus 1. This is the same thing with the negative sign. And then when you're looking at the cosine inverse, is the same as sine inverse with a negative sign, and I've mentioned the dx. Now, let's do this, and I want to look at the proof. In order to differentiate this, I'm going to look at this one, everybody, its definition. So I'm going to differentiate this one. So when sine inverse of x is y, by definition, sine y equals x. So if I want to differentiate this, I'm going to differentiate it implicitly. The derivative of sine is cosine, but cosine y times y prime or dy dx, and x gives you 1. Cosine y dy dx equals 1. This is implicitly knowing y is g of x. So you can say cosine of g of x and then times g prime of x by the chain rule. Therefore, dy dx is 1 over cosine y. Now, what is cosine y? If we go back to this one, if sine y is x, we can find cosine y because we know sine squared plus cosine squared is 1, right, class? Sine squared theta plus cosine squared theta is 1. It's a Pythagorean identity. Therefore, if I want cosine y, I put square root of 1 minus sine squared y. And since sine y equals x, I'm going to replace the sine y with x. I get the square root of 1 minus x squared. And now I'm going to replace it right here. And therefore, the derivative of sine inverse of x is 1 over cosine y, which is replaced by square root of 1 minus x squared. This is the proof, everybody. Let's look at tan inverse. In the case of a tan inverse, remember tan inverse of x equals y means tan y equals x. And this happens when y is between negative power 2 and power 2. And we want to prove that its derivative is 1 over 1 plus x squared. We want to prove that. So to prove that, we're going to start with this. And we are going to differentiate it implicitly. Tan, as you know, the derivative is secant squared. So secant squared of y dy dx equals 1. So what is dy dx? 1 over secant squared y. We also know one of those Pythagorean identities, 1 plus tan squared is secant squared. So if secant squared is 1 plus tan squared, and tan of y is x, so this is x squared, everybody. This is x squared. So replace the secant squared y with 1 plus x squared. Dy dx is 1 plus x squared. So we proved the derivative of tan inverse is 1 over 1 plus x squared. You can always try a couple of examples on your own. For example, you can work on secant inverse. See what you get. All right, we want to differentiate y equals e to the power of 10x times tan inverse of x, and I'm going to put a raised dot between these two. So this is the f function, this is the g function, and we are going to use the product rule. So we need f prime, so e to the power of 10x is e to the power of 10x times 10, that's f prime. Now g, just put the tan inverse next to it, plus g prime. What is the derivative of tan inverse? Is 1 over 1 plus x squared, and then times f times e to the power of 10x. So basically 10 sits in front. We can put this at top of that. I mean, you can factor the e to the power of 10x out, but it doesn't simplify it. You can leave it like that. Either way is fine. Y equals cosecant inverse of some function of x, e to the power of x, or even you can think of it as g of x even. You can think of this as some function, g of x, or just u. So first, I want you to look at the basics. And it says you put -1 at top, you put something here, you put x, and then square root of x squared minus 1. Well, instead of x, what do we have to put in? Whatever this one is, u, e to the power of x. However, since this is not x, we need, according to this, we need du dx. And the derivative of e to the power of x is e to the power of x. Whether you put it at top or next to it makes no difference. Now we're going to rewrite this by putting this at top, minus e to the power of x over this. These two cancel each other. And we are left with -1 over square root of e to the power of 2x minus 1. By the way, I hope everybody knows that e to the power of x quantity squared is e to the power of x times 2 or 2x. So pay attention to this concept, okay? You just tag along du dx or g prime of x. We want to differentiate x times sine inverse of 3x. So number one, I'm going to put a raised dot in between x and sine inverse. Therefore, this is the f function, and this is the g function. So first you need f prime, which is 1, times g. We are looking at the product rule again. F prime is 1 times sine inverse of 3x. Now we need g prime times f. Now, what is g prime? Take a look at the sine inverse and write it in this fashion, class. What happens here that you have to put the 3x in here. Over here, it's 1. However, if you're taking the derivative of sine inverse of u, call this u or g of x, call it u or g of x. Therefore, du dx or g prime of x is 3. So you can write it here or here, it doesn't matter. So this one, we put 3x, this one we put 3. So we are done with calculus. We are going to rewrite it. This is sine inverse of 3x. This is simply 3 and this is 3 over square root of 1 minus 9x squared. We have to multiply it by x. My apologies. The g, I forgot to mention g prime f. You have to multiply it by x, right? Let me write this in this fashion. What color do I need? Let me write it again. So this is f prime g. This is g prime f. And so let's put it at top. The top becomes therefore 3x for the second piece. Let's look at the derivative of y equals x cosine inverse of x minus the square root of 1 minus x squared. Well, two things we need to do. We need to change this to 1 minus x squared to the power of 1 half. That's one thing we need to do. The other thing is I'm going to put a raised dot in between here, and meaning that this is the f function. Cosine inverse is the g function, and I'm going to use the product rule on this. So f prime, the derivative is 1 times g cosine inverse of x. So 1 times cosine inverse of x plus g prime. Cosine inverse of x is negative 1 over square root of 1 minus x squared. Negative 1 over the square root of 1 minus x squared. Times f times x. And this one, we are going to look at the top one and use the extended power rule on that. So minus 1 half 1 minus x squared to the power of 1 half minus 1, which makes it negative 1 half. 1 half minus 1. 1 half minus 1. And then by the chain rule, the derivative of the inside requires minus 2x. And let me put an asterisk next to it, class. This is the only calculus step. Now, of course, we're going to use algebra to finish the job, starting with the first one. This is cosine inverse of x. This one is minus x over square root of 1 minus x squared. Let's see what this is. Let me rewrite the whole thing, makes it easier to see that. So we have a negative sign here, negative sign. Fraction bar. At top, we have negative 2x. At the bottom, we have this 2. And this has a negative exponent. We take it down and we write it with a positive exponent. So what do we have here? Negative and negative is positive. These two cancel each other. And this one, we write it as a square root. So notice this is identical to that. One is negative, one is positive. These two cancel each other. And you're left with cosine inverse of x. So given y equals x cosine inverse of x minus the square root of 1 minus x squared, dy dx or y prime is simply put is cosine inverse x